Assalamu alaikum students. Hope all of you are fine by the grace of Almighty Allah. Today I will discuss about stoichiometry. I think this term stoichiometry is new for you, but this is very important topic of quantitative chemistry, and this is the branch of chemistry, the branch of quantitative chemistry, which deals with the measurement of products from the amount of reactants and also the measurement of reactants from the amount of products is known as stoichiometry. And the informations that can be gathered regarding mole concept, regarding mole from any chemical reaction is known as the stoichiometry of that chemical reaction. Stoichiometry measures the quantitative relationships between reactants and products in a chemical reaction. And we don't need a lab full of sample chemicals to do the stoichiometry. Just only a pen, a calculator and some information regarding mole are enough to do the calculations. Okay, and let's take a simple chemical reaction. Okay, this is a gaseous chemical reaction. All the reactants and products, all the substance are gaseous form. Okay, in gaseous form, and here nitrogen reacts with hydrogen. That means nitrogen combines with hydrogen and produce ammonia gas. And this is not a balanced reaction. This is not balanced reaction, balanced equation. And in that case, the reactants and reactants combines on the left side to yield the product on the right side. And during the reaction, we know new bonds are broken in the reactant sites and new bonds are formed in products. But the number of atoms of each element remains the same. That means it follows conservation of mass. When writing a chemical reaction as a chemical equation, then the number of atoms of each element has to be exactly the same on both sides. Okay, on product side and also reactant side. And this is known as equation balancing. This is known as equation balancing, and for stoichiometry, the balancing of chemical equation is very important. This is very important, this is very useful for understanding the chemical proportion, the proportion of different chemicals as they reacted at a molecular level. Okay, at a molecular level. But in practically, we cannot deal with atoms or molecules. Practically in a lab or in industry or in our life, we have to work with a measurable amount of substances, and we have to take chemicals by measuring using real scale. That's why we have to need applying the stoichiometry concept to calculate specific mass of reactants and products. And also we need a balanced chemical equation, and for balancing this equation, this is not balanced. For balancing this equation, we have to add some coefficients in front of these molecules. Okay, and which is 3 for this production and 2. That means 1 molecule nitrogen gas reacts with 3 molecule hydrogen gas and produce 2 molecule ammonia gas. Okay, that means the ratio, that means we have to know for better understanding of stoichiometry, we have to know the significance of coefficient. Okay, coefficient. Okay, coefficient are represent a specific amount of any substance. Okay, specific amount of any substance, and also represent the ratio of the reactants and products in a chemical reaction. Okay, we can measure ratio from that. Nitrogen 1, and then hydrogen will be 3, and the product ammonia is 2. That means nitrogen and hydrogen always reacts with 1:3 ratio and produce 2 ammonia. Okay, and then suppose we take 2 more nitrogen, 2 molecule nitrogen, and then these 2 molecule nitrogen reacts with 6 molecule hydrogen and produce 4 molecule ammonia. And if we take 3 nitrogen, then 3 nitrogen reacts with 9 molecule hydrogen and produce 6 molecule ammonia. And now if we calculate the ratio, the simple ratio, then we get, for every case we get the same ratio, which is 1:3:2. Okay, for that 1, 3 and 2. For that also 1, 3 and 2. Okay, that means for any chemical reaction, the coefficients of the reaction are same, are constant. Okay, and that represent that always a certain amount of reactant reacts with a certain amount of another reactant and produce a certain amount of specific amount of product. And these coefficients also tells us how many particles or molecules are reacting in a chemical reaction and how many particles or molecules will be produced. Okay, and now we have to practice some problems regarding the mole concept, and before that we have to know the stoichiometry of a chemical reaction. From stoichiometric study, which informations can we get? Okay, from any chemical equation. Okay, then at first these coefficients tells us the number of molecules, about the number of molecules. That means here the number of molecule is nitrogen 1 molecule nitrogen, 3 molecule. Okay, molecule 1, 3, and this is 2. And we know the one molecule, that means the molecular formula, from the molecular formula the molecular mass will be 1:28. 28 is the molecular mass of nitrogen molecule, and this will be 3:2, and this will be the molecular mass of ammonia is 17. That means 2:17. These are the molecular mass of corresponding molecule. Okay, and after that we know, if we express the molecular mass in gram unit, then this amount is considered as mole. Gram, then 28 gram, this is 3 into 2 gram, and this is 2 into 17 gram, and this 28 gram represent 1 mole of nitrogen. This 2 gram into 3 mole of hydrogen, and these 2 times 17, 2 mole ammonia. Okay, student, and also from this balanced equation we get these informations: number of molecules, molecular mass, the gram weight, mass, gram mass, and the number of moles. And also we can get the number of molecules. Okay, if we know 1 mole of any substance contains Avogadro number of molecules. Okay, and this number is 6.023 into 10 to the power 23. That means the number of molecules will be 6.02 into 10 to the power 23 molecules. Okay, and for this 3 mole, that means 3 into 0.02 into 10 to the power 23 molecules, and here 2 mole ammonia is present, so the number of molecules will be 2 into 6.02 into 10 to the power 23. These all informations are considered as the stoichiometry of this equation. And for any gaseous reaction, we can add another information. For any gaseous reaction, if the reactants and products are gas, then at STP, that at standard temperature and pressure, we know any gas at STP contains 22.1 mole of any gas contains 22.4 liter volume, and this is known as the molar volume of that gas. Okay, so we can also find can get the information about molar volume. Then the volume will be for any gaseous substance. This volume is only applicable for gaseous equation. Okay, and this will be, this is 22.4 liter, and for this 3 into 22.4 liter, and this will be 2 into, this is 3 into, and this is 2 into 6.02 into 10 to the power 20. Sorry, this will be 22.4 liter. All these informations are known as the stoichiometry of this equation. And using these informations, now we have to do some problems, mathematical problems. Okay, and first of all, the problem 1 I have already written on board. One is how many moles of nitrogen, sorry, this equation is needed. Okay, hydrogen gas and 2 ammonia gas. How many moles of nitrogen are needed to react with 7.5 moles hydrogen? Nitrogen are needed to react with 7.1 moles hydrogen, and these types of reaction problems, or maximum problems of these stoichiometry related to this stoichiometry, we can solve this by different way, mainly 2 ways: mole calculation, using mole calculation, or gram calculation. Okay, we can convert mole into gram at first, then can calculate, and also we can calculate using the mole. Okay, and at first for first problem I want to use the mole calculation. Okay, mole concept. Then we know the coefficient here. This is our given. Okay, this is our given amount. That means hydrogen, the amount of the mole number of hydrogen is given, and we have to calculate the number of moles of nitrogen. That means, and these two chemical, these two substances are the reactant of this reaction. Okay, that means for calculating this problem we have to look at this side only. Okay, because we have to quantify the reactants. That's why these informations will be needed. Okay, and from the coefficient we get easily the ratio of the reactants molecule. Okay, and this ratio is, and at first we have to take 7.5 mole hydrogen, and then the ratio can be used. We use 3 hydrogen here and 1 nitrogen, and if we calculate yes, 2.5 mole of hydrogen, nitrogen. Okay, that means 2.5 mole nitrogen reacts with 7.5 mole hydrogen, and then a certain amount of ammonia will be produced. Okay, and you can check it. This is also 1:3 ratio. This is 1 and this is 3. Okay, and this can be, and you can also use the unitary method. From unitary method we get this overall, and in your book the unitary methods are followed. You can also do the problems by following unitary method. And then number 2, this is also regarding this equation, and how many grams. Now we have to calculate the gram amount, mass. Okay, mass of substance, and in that case the mass of ammonia is required. We have to calculate the mass of product. Okay, that means how many grams of ammonia is produced from 42 gram nitrogen gas. Okay, that's why we have to look at both sides. This is the product and this is our reactant. That means now I follow the unitary method, and at first we have to calculate the gram. Okay, that means we calculate the from molecule to gram. Okay, and then that means it's 1 mole, 3 mole, 2 mole. Okay, and 1 mole, if we express it in gram unit, then we get 28 gram nitrogen. And for here, this is not needed for solving this problem, so we can skip this. And this is 2 into 17. Okay, 2 into 17, 34 gram. Okay, and now we can follow the unitary method. And so 20, from this balance equation we get the information 28 gram nitrogen reacts to produce 34 gram ammonia. Okay, so 1 gram 34 by 28 gram, and our given amount is 42 gram produce 34 into 42 by 28 gram ammonia. Okay, and you have to calculate and put the answer here. Okay, and this is our second problem. I think it is clear to you. We can use the mole when our required quantity is mole, and if our required quantity is mass, then we can convert the mole into gram unit and then use this gram quantity for calculation. Okay, and now the problem number 3. Now we have to calculate the number of molecules. The number of molecules and how many ammonia molecule will be produced from 5 gram nitrogen molecules. Here also we have to look at the both sides. Okay, we have to find out the relation between one of the reactant with the product. And we know similarly, at first we have to show the mole number 3 mole and 2 mole, and we know 1 mole contains Avogadro number of molecules. That means here 6.023 into 10 to the power 23 molecules react with hydrogen and produce 2 into 6.023 into 10 to the power 23 molecules ammonia. Okay, this is our stoichiometric information we get from the balanced chemical equation. For this stoichiometry, of course, we have to start with balancing the equation. Okay, for doing these types of problem, stoichiometric based problem, we have to start with balancing the equation. Okay, and now we can easily calculate the number of molecules of ammonia. Two 2.63 into 10 to the power 23 molecules nitrogen produce 2 into 6.023 into 10 to the power 23 molecules ammonia. So 5 molecules nitrogen produce how much? Okay, 0.6 to 6.023 into 10 to the power 23 into 5 by 6.023 into 10 to the power 23. That means we have to get 10 molecule ammonia. The answer will be 10 molecules ammonia will be produced when we use 5 molecule nitrogen gas. And students, I think these simple problems are clear to you, and you have to practice some more problems with some different chemical equations. And at first you have to balance the chemical equation, and after that you will solve the problem. And keep practicing. That's all for today. Assalamu alaikum.